Hey, it's still 2.5. I think this is part 4. I know there's a lot of examples, but this is especially where people have difficulty, so I want to go through a lot of examples. Kind of like the last example, we're still kind of building up to be able to write our own 2-column proof. Like normally you would just be given, the proof, and then a diagram, and then you have to set everything else up. And for most people, that's where they really start struggling. So here, a lot of it's already set up for you. Certain statements are already given, certain reasons are already given, and we just need to fill in either the missing reasons or the missing statement. Okay, but we still want to go through and then look at each of the individual parts. Maybe even start putting some things into the diagram. So it's given that AB, that segment, and CD bisect each other at point M. So if they bisect each other at point M, that means they cut each other into 2 congruent parts. You have to keep that in mind once we're trying to figure out certain reasons. Segment BM is congruent to segment CM. And then you want to prove that the length of AB is equal to the length of AM plus the length of DM. So the first statement's already given. Segment BM is congruent to segment CM. The first reason's already given as well. That's right here. It was given, so the reason is given. And then the second statement, CM, this segment right here, is congruent to DM. So I'm going to mark that in my diagram. But do you know, and then kind of like the last part of the video, part 3, I said you might need to pause to kind of think about what you're doing. But what says you can make the statement segment CM is congruent to segment DM? Okay, so since it's given, whoops, I should circle that whole thing. Segment AB and segment CD bisect each other, then M is the midpoint of both CD and AB. CM is congruent to MD or DM. So that's a definition of segment bisector. And then for the next statement, segment BM is congruent to segment DM. So kind of like the last example as well, you always have to look at previous statements. You might need to look at statements ahead as well, especially if they're already given. But segment BM, that's right here, is congruent to segment DM. So it's given that segment BM is congruent to segment CM. Segment CM is congruent to segment DM. Kind of like the last example as well, you can kind of use one of two things here. You could use the substitution property, because if segment BM is congruent to segment CM is congruent to segment DM, you could substitute segment DM in for segment CM since they're congruent. So again, you could either say substitution or you could actually also say the transitive property. Be careful here, though. It would technically be the transitive property of congruence. It's not the transitive property of equality. If you just said transitive property, that's fine. But we're talking about congruent segments, not equal segment lengths. That's why it would be the transitive property of congruence as opposed to equality. There is a difference there. Congruence, you use congruence. And then equality, you use an equation. All right. And then statement 4 is given. The length of BM is basically what this states is equal to the length of DM. If you look at the previous statement, the 2 segments are congruent, then the lengths are equal. Maybe you think about it, pause. But that would be the definition of congruent segments. Segments are congruent, then their lengths are equal. Okay, and then the next statement is unknown, or we need to figure it out. but we do know the reason, the segment addition postulate. So don't forget the segment addition postulate basically states the sum of the parts is equal to the whole. So I have a couple of segments in here. Segment CD, like segment CM, that length plus length of segment MD would equal the length of segment CD, or the longer segment AB as well. The length of AM plus the length of MB is equal to the length of AB. In order to figure out which one we want to write, if you look at the next statement right here, it's talking about the length of AB. So I really don't want to use the first thing I said. You'd use the second thing I said. Segment AB, that entire segment is equal to segment AM's length plus the length of segment MB. And notice certain things match up from statement 5 to statement 6. The length of AB, the length of AB, length of AM, the length of MB. Ooh, one part doesn't match up because if they matched up exactly, we wouldn't need the sixth statement. Okay, but that's using the segment addition postulate. And then notice that these two things change. We went from the length of MB to the length of DM. And I wrote the length of MB. I could have also written the length of BM. Maybe it would have been easier to see exactly what the reason is if I wrote it like that. Because on the previous statement, they're talking about, or they're using the length of BM. You could write it either way. But instead of the length of BM from statement 5, in statement 6, we have the length of DM. Those two lengths are equal, so we can substitute in the length of DM for the length of BM. And that's what we just use, substitution. I just write substitution. So obviously, or maybe not so obviously, you could write that as well. If you wanted to be more specific, you could write the substitution property of equality because we're substituting in the length of DM for the length of BM. We've completed the two-column proof by filling in all of the reasons and the only one statement that we needed to fill in.